Alright guys, today we're going to talk about 7-3. Our objectives are to prove certain triangles are similar by using angle-angle, side-side-side, side-angle-side. Use triangle similarity to solve problems. Okay, our first theorem, angle-angle similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So what you have here is you have angle A and angle D congruent because of the markings, angle B and angle E congruent because of the markings. Therefore, you know that triangle ABC is congruent to triangle DEF. Notice how when you write the congruency statement that you start with ABC, you have to be very precise. D corresponds with A, so it's D. E corresponds with B, so it's E. And then F corresponds with C, so it's F. How do we know that we can use angle-angle similarity? Well, you all know that angles C and F are congruent because of your triangle-angle sum theorem. All three angles in a triangle are 180, so if A and B are congruent to D and E, therefore you know C and F are congruent. All right, so let's apply this. Explain why the triangles are similar and write a similarity statement. Okay, so we have no side measures, but we have an angle measure. We know that angle A is congruent to angle D. And how do we know that? Because it's the definition of right angles. All right angles are 90 degrees. What do we know about these two angles? So that's angle BCA congruent to angle ECD. And these are vertical angles. We all know that vertical angles are congruent. Therefore, we have two corresponding angles congruent. So you can say that triangle ABC is similar to triangle. What corresponds with A? D. What corresponds with B? E. And then C. And this is because of your angle-angle similarity theorem. Explain why the triangles are similar and write a similarity statement. Okay, well we know that angle B is congruent to angle E, definition of right angles. Okay, we have angle A and we have angle F, which are not congruent. But how can we find the measurement of angle C? Well, measurement of angle C equals, if this angle is 90, then the sum of these two angles is 90. So just take 90 and minus 43, and you get 47. Okay, so we have angle C, which is 47, congruent to angle F. So we can say that triangle ABC is similar to triangle. What corresponds with A? Well, D is 43, A is 43, B is the right angle, and C is the 47. And this is because of your angle-angle similarity. Okay, another theorem here, side-side-side similarity. Kind of like the side-side-side congruency. If the three sides of one triangle are proportional to the three corresponding sides of another triangle, then the triangles are similar. Okay, so let's look at this one. Oh, got another theorem here. Your side angle side. If two sides of one triangle are proportional to two sides of another triangle, then their including angle, make sure it is the including angle. Angle B is included in AB and BC. Angle E is included in DE and EF. Then the triangles are similar. So we need on this one start thinking side, 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 because all we have here are side measurements. Okay, so let's set up our similarity. Boy, that's awful. So we have PQ. Well, PQ corresponds with ST. PQ is 3. ST is 4.5. And when you simplify that, you get 2/3. Then we have PR. PR corresponds with SU. PR is 2. SU is 3. And then we have our last one, QR. QR corresponds with TU. TU. QR is 3. TU is 4.5. When you simplify that, you get 2/3. All corresponding sides are proportional. So we can write our similarity statement. And I'm going to use this one right here. Triangle PQR is similar to triangle STU. How do we know that? Side, 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 similarity. Okay, on this one I have an included angle and 2 side measurements. So we want to think side, angle, side. Alright, so let's start with the easy one. We can say that angle D is congruent to angle H. Definition of congruent angles. Alright, so we have side DE. DE corresponds with HJ. Well, DE is 2. HJ is 1, so that simplifies to 2. And then we have measurement for DF. Well, DF corresponds with HK. DF is 5.8. HK is 2.9. And that ratio simplifies to 2. So we have the 2 corresponding sides proportional. And we have the including angle congruent. So you can write your similarity statement. DEF is similar to HJK because of side, angle, side similarity. Alright, explain why the triangles are similar and then find CD. Okay, so we have ABE, the smaller triangle, and ACD, the larger triangle. So, we can't use any side measurements because we have X for DC, so we need to start thinking angle similarity. Okay? So, we have angle, what is that? EBA, EBA, congruent to angle DCA, DCA. Why? Definition of right angles. We're talking about this angle and this angle. All right, we need one more angle. Can y'all see it yet? What do you know about the measurement of angle A on triangle ABE and the measurement of angle A on triangle DAC? They have to be congruent. It's the same angle. That is your reflexive property. Okay, now we can say the triangles are similar. Triangle ABE, ACD, because of angle similarity. Once you've proven they're similar, you can write a proportion to find out the measurement of CD. Okay, so we have, let's say, AB. AB goes over AC. Well, AB is 9. AC is 9 plus 3, which is 12. And what's that simplify to? 3/4. All right, and then we have EB. EB corresponds with DC. EB is 5, DC is X. Well, what do we know about these two ratios? We know that they have to be equal to each other. So you can do your cross product and solve for X. 3 times X, 4 times 5. Divide both sides by 3. And you're going to get 20 over 3. And the question is find CD. Well, CD equals 20 over 3. If you want to change that to a mixed number, you may, and that would be 6 2/3. Do not change it to a decimal because it won't be precise enough. All right, last one's going to be a proof. Given 3UT equals 5RT and 3VT equals 5ST, prove that the triangles are similar. All right, so let's start with our first given statement. 3UT equals 5RT. This is given. Okay, so what we need to do here is we need to find a ratio and get rid of some of these letters. Okay, so if I have 3UT equal to 5RT, I can divide this side by 3, and it will cancel out that 3. Divide this side by 3. But then I'm still going to have this RT. I need the RT over here, so let's divide by 3RT. And when you do that, you get UT over RT equals 5/3. And now I have my ratio. And the reason for this is you divide by 3RT. Okay, then let's start with the second part that's given. 3VT equals 5ST. That is given. So again, I'm going to take 3VT and divide by 3ST. 5ST and divide by 3ST. Okay, so this ratio simplifies to VT over ST equal, this ratio simplifies to 5/3. Reason is we're dividing by 3ST. Okay, two corresponding sides equal to each other. So now I've got two sides. I don't have a third side. However, what do y'all know about these angles right here? Those are vertical angles. So we have angle RTS congruent to angle UTV. Vertical angles are congruent. And then your last statement is what you're proving. Triangle UVT is similar to triangle RST. And how do we know that? Side, angle, side, similarity. All right, last part. If you can remember in Chapter 2, the reflexive, symmetric, and transitive properties of equality have corresponding properties of congruency. These properties also hold true for similarity of triangles. So your reflexive property, triangle ABC is similar to triangle ABC. There's your reflexive property of similarity. Symmetric, if triangle ABC is similar to DEF, then triangle DEF is similar to ABC. Switching the order there. And then the transitive is if you have one triangle similar to the second triangle, then that second triangle is similar to the third triangle, then you know the first triangle is similar to the third one. Transitive property. And that's it, guys. Have a good one.